On behalf of the CMU Portugal program, I would like to thank you all the participants who have registered in the talk. Also, a special thank you to Professor John Zimmerman from the Human-Computer Interaction Institute of Carnegie Mellon University for his availability to give this talk. So the session will have 1 hour of duration, 45 minutes for the presentation, and 15 minutes for questions in the end. Please keep your microphone muted and camera turned off for the session. Should you have a question, please use the Q&A section to question Professor John, stating your name and affiliation. We have here with us Professor Nuno Nunes, the CMU Portugal Program Co-Director. We'll welcome Professor John and make a general overview of the Advanced Training Program in User Experience Design, and also Professor João Guerreiro from Faculty of Sciences of the University of Lisbon to make a brief introduction of Professor John. So thank you.
Thank you, João. Welcome everybody, good afternoon. It's my pleasure to be here representing the Carnegie Mellon Portugal International Partnership, and especially to be here for the opening of this User Experience Design Advanced Program, which we will be starting soon. These are just the initial talks that hopefully will persuade you to enroll in this program. It's been a tradition of the Carnegie Mellon International Partnership to have some kind of training which is much more directed to the industry needs, and this is why we have selected two programs, data science, which already had some of the initial talks, and now we will start this one on user experience design. And I was saying we have beaten the record number of participants. I think this is, of course, because we have a great speaker, my friend John Zimmerman, which is a pleasure to have him here, collaborating again with us. Also because we have very two committed persons who have been devoted to advertising this program, João Guerreiro and Diogo Cabral, from two of the institutions that are collaborating in the program. The program involves 3 universities, the 3 main universities or schools, 2 universities and 3 schools of Lisbon. Again, this is something new, and it's good to have everybody in the field collaborating. And finally, I would like to thank very much the executive team, which as always have been working very hard behind the scenes to make sure that all is happening. João Fumega, who is our educational officer, but also Silvia Castro and Mariana, who made this possible. And without further ado, I'll pass on to João Guerreiro to introduce John, and I will be attending the seminar and hope to see everybody who I can't see right now because this is a webinar platform. I hope to see you soon when we open the advanced training program, hopefully if COVID permits after the summer.
Thank you, Nuno. Hi, my name is João Guerreiro. I'm an assistant professor at Faculdade de Ciências da Universidade de Lisboa and a researcher at LASIG. I'd like to welcome everyone to the first talk of the User Experience Design series. I have the pleasure to introduce John Zimmerman, who is the Tang Family Professor of Human-Computer Interaction and Artificial Intelligence at Carnegie Mellon University. He's part of the Human-Computer Interaction Institute, known as HCII, which is one of the pioneers and leading HCI institutions in the world. John has 20 years of experience designing and researching human-AI interaction, and has been collecting a large number of awards with his scientific contributions in the flagship venues in the area. He's also known as one of the founders of research through design practice within HCI. His current areas of research include intelligent systems for professionals, interaction with social robots that function as proxy people, and how designers can better engage with AI as a design material. He also teaches courses in user experience design, service design, and design of AI products and services. So today, John Zimmerman will talk about designing systems that blend human and machine intelligence. I'm looking forward to hearing our speaker, and without further ado, I'd like to give the floor to John.
Hi, everybody. Thanks for having me here. It's very exciting. I just want to share some new ideas that I'm working on in the space of human AI interaction. I start with some theoretical background, go over a little bit of my prior work that informs the new work that we're doing, and then sort of take three different views of professional AI interaction, and then finish with just some emerging insights about this area. And to really start, I want to ground this in Schoen's definition of what we mean by professional. And it's really just anyone that has specialized knowledge and training or expertise that allows them to step into a really messy situation and use that expertise and intuition to take action, often in spaces where others would struggle. And sort of just to lighten the mood a little bit, a little meme here. But to really capture this idea of professionals, professionals take action in a wildly different way than amateurs, and you can sort of distinguish when someone is a professional because they have an entirely different way of working. And we know a little bit about intelligent systems that have been designed for professionals, and largely they fail. Not typically because of the AI, it works great in the lab, but when you move into the real world, things start to break down. And what we know from the literature is often the systems ignore what motivate people to select and choose the services for their work. So they're not paying attention to how professionals make choices. They're applying machine intelligence to the wrong problems, often attempting to replace the professional as opposed to supporting or supplementing them. And many of the systems that they build are outright disrespectful of the professional's expertise and intuition. And they'll often view that professional as a problem to be overcome. And I have a little image here, a Boeing 737 MAX, which I think is a great example of this, the integration of AI systems that fight with pilots, and in their design, we're very much viewing pilots as a problem to overcome. So indulge me a little, I'm going to shift away directly from human AI interaction just to cover some theory and to talk a little bit about work that informs what we're doing. And I want to start by putting out this idea that value is a perception inside of people. So it can be changed, but it's not like a real thing. It's just an internal state. And what's frustrating to me as an interaction designer is that people perceive digital things as less valuable or as worth less in comparison to non-digital things. So the example I have here is a $900,000 Patek Philippe watch. It's shiny, it tells the time and the date. Apple, as much as they have tried to co-brand with Hermès and other things, really can't sell a watch for more than $1,500. There's something about the digital that doesn't really allow it to become a luxury product or collect that kind of value. A different view on this. I'm sure many of you had parents that read to you when you were children, and often will visit parents in their home and discover books that they've kept that they read to their children years before. What's interesting is if a parent read to their child on a Kindle or an iPad, even though it is a material artifact in their hand during the intimate encounter with their child, they would not keep and cherish the Kindle or the iPad. So somehow value is accruing differently for our digital things than the non-digital ones. And in thinking about how people construct value, I like to draw on Russell Belk's work and his theory of extended self. So he builds on Sartre's 3 states of existence, and he talks about people having things, they have possessions, and that allows them to engage in doing something. And in that process of both having the thing and using it, they develop a sense of who they are in relationship to the thing. And this is how people construct that sense of value for their possessions. Now, this work has been extended by the Kleins, who applied a social identity theory perspective. And this very weird looking image is actually meant to be a person. And in the center is their core self, but that core self is surrounded by all of the different social roles that they enact. So myself, I am a son, I'm a father, I'm a husband, I'm a teacher, I'm a colleague, I'm a mentor, I'm an underling, right? I play all of these different roles based on a relationship match I have with another person. And what the Kleins discovered is, so for social roles that are important, people develop a sense of who they are and also of who they desire to be. And as they make consumptive choices to bring new people into their lives, new places, new products and services, those are mediated by their idealized self in a specific role, not by the core self. And so, like, very reductively, trying to extract from all this theory on possession attachment, what we know is people gravitate towards the thing they feel is helping them become the person they desire to be in a specific role. And so the question is, should we make computationally intelligent things that have an intention of helping people move towards that idealized self in a role? And I throw in this picture of the OJ car chase just to capture the idea, this is entirely unconscious. This value construction is taking place, but people are not aware of it. And what I find fascinating about the OJ car chase is that sales of white Ford Broncos increased shortly after the chase. That's a sign of people sort of gravitating towards this thing in a very unconscious way. So this idea of designing for the self is making things that have an intention of moving users towards their desired self, not telling them who they should be, but helping them move towards whoever it is they want to be. And it fundamentally is around problem selection and a respect for the human actor. So I've done a bunch of work in this space, particularly focused on dual income parents who are definitely not professionals. They're very different. And dual income parents are interesting because they're sensitive to feel like bad parents because they chose to work instead of staying home with their kids. They also really think technology is something that can help them. And they have a bunch of complicated logistics that make their life difficult. And so we made a number of things for them. One was an reverse alarm clock. And this is due to the problem, like children wake their parents up at night. And when the parents are sleep deprived, they have less emotional reserve in the morning to sort of get everyone out the door without yelling. And so we made a clock. It just abstracts time into 3 states. When the moon is up, the rule is the child has to be in bed. When the moon sets, the child can get out of bed if they want. And when the sun comes up, they have to get out of bed. So it's very simple. It's an information display for small children to learn to start to make decisions. And it's not holding kids in bed, but it's working in support of the rules that the parents have established, but giving kids information to make choices. Other work we've done, we've collected a bunch of work on families. This is 6 months of a single family with a mom, dad, a 15-year-old son, and a 10-year-old daughter. And we were tracking how many activities are routine, how many are scheduled deviations, like, oh, today I have a doctor's appointment, it's going to be a little different, or unscheduled, like, oh, my child was sick today and my plans for today have to change. And what we find is parents create routines to be able to do all of the work of parenting without having to give it 100% of your attention. But when they deviate, then they really have to attend. And that's typically when breakdowns take place. And what we found is about 90% of days have a deviation. So they're likely to experience some kind of failure. And in supporting parents, we made this system the person, place, time view. And what it does is it learns where and when everyone in the family is going to be. It makes a prediction. And it predicts which parent is most likely going to be the one doing the pickups and drop-offs of kids at different activities. And the real value of this is it can tell when is there a child that probably should be being picked up, but no parent appears to be heading towards the child. And so it's like a smoke detector for forgetting your kids. And it's really just lowers parents' anxiety. People don't forget their kids that often, but they carry that anxiety constantly. So can we think of technology as a way of reducing anxiety and stress? The last example I want to talk about very quickly is just looking at kids' activity bags. So parents will pack a bag for their kids for an activity like football. On Tuesday when your child is playing, the bag is ready, everything's in it. Kids do things like take their cleats out and don't put them back in, and suddenly you're the parent that took your child to football without their cleats, which is not an awesome performance of parenting. And so we simulated this idea of if we had a smart bag that understood what the schedule was, it could support parents in packing the bag. And then we tested this through a method called speed dating with our very fake smart home. So we would give parents shopping bags, ask them to come into a smart home. They would walk past a smart washer and dryer, and it would be like, hey, Johnny's soccer shirt is clean and ready to go into his bag. And instead of saying, awesome, parents were like, why are you telling me? Why aren't you telling my kid? And we had never seen, in all the homes we've been in, we'd never seen a kid pack a bag. And when we pushed parents on this, they said, oh, I don't really care about getting to football with all of the gear. What I really care about is raising responsible children. Can you build me a smart home that helps me raise responsible children? And that is not at all what we had been working on. So some insights from this prior work was really doing the work of parenting is important. So people did not want us to automate parenting, but we could apply AI to sources of stress. We could free up attention, and we could situate technology that helps parents focus on their long-term goals, not just the sort of short-term noise and needs. All right, so now I'm going to take this shift and really talk about AI for professionals and start with some work we've done in decision support. And so we were working on a project for cardiologists who implant mechanical hearts. So this is called a VAD. It's a little propeller that moves your blood around when your ventricles begin to break down. And what we know from the data is lots of patients that get these die shortly afterwards. So it appears that there is some bad decision making. Clinicians can draw from their experience of hundreds of cases, but AI can consider millions of cases. So is this an opportunity for AI to really improve decision making? Now, there's a number of assumptions that AI developers in doing healthcare work have made. One, a set of these is that clinicians know they need help, that they want to have help in making critical decisions, and that they have free time where they can walk up and use a separate IT system to explore a problem and get advice. And so we sort of abandoned that view and went and did field work at 3 different sites where doctors implant mechanical hearts. And what was super interesting was they did not consider this a difficult decision at all. They're going to give you drugs until the drugs don't work, and then they're going to decide if you can have a VAD or not. All of the clinicians we talked to viewed themselves as exceptional. So if you said 50% of the people like this that are going to have an implant will die, they would say, yeah, but not my patients. They were openly hostile to the idea of AI helping. And we found that their decision process was actually very collaborative and informal, but it was taking place in hallway conversations far from computers. But what we did see is they had a weekly meeting. It was super hierarchical, where they discussed all of the patients that might be surgical. And we saw all these, what we call the mid-levels, nurse practitioners, medical students, social workers who had a lot more touch time with the individual patients, who were supposed to be participating, but in no way felt empowered to challenge one of the doctor's decisions. From our fieldwork, we extracted 3 patient journeys. There's the textbook case where they sort of, the black line, they're increasing medication from oral to intravenous to VAD consideration to VAD. Then there was the sort of emergency room path, the orange line. There's a patient at home, and that patient is suddenly sick, and if they don't have a VAD, they're going to die. And there's not enough data to really help with that decision. The textbook case is sort of like where they don't really need a lot of help because they're just following their textbook procedure. But then there was this other path, the blue line, it's the late referral path. And what we found is a number of patients have a cardiologist that doesn't do implants, because very few cardiologists do this. And that cardiologist doesn't know when to refer them. So they were referring their patients too late. They were now too sick to survive the surgery. So the implant cardiologist is sort of given a patient with this choice. I can either give you a VAD and you will likely die, or I cannot give you a VAD and you will definitely die. And this seemed to be a cause of many of the high numbers of fatality shortly after surgery. So in thinking about how could we make a decision support system to sort of work at this moment, we knew it wasn't really needed for the textbook cases. So how do we make a system that kind of stays out of the way of most of the work that's passing through? How could we increase the influence of mid-levels and sort of increase the collective intelligence of the group? And then how do we slow down decision-making for cases that seem like they're textbook, but maybe they're not? Particularly when we have people that don't want to use a computer and when the AI has no concept of what is or isn't a textbook case. So the interface we developed, we kind of frame as unremarkable AI. This comes from Ptolemy's work and Weiser's work with the idea that like electricity is unremarkable. You don't notice it till it's missing, but it's not trying to be in your way or taking your attention. So we really wanted the AI to be very unremarkable. And what we did was automate the process of creating slides for their weekly decision meeting. And then we threw up a survival curve in the upper right-hand corner because we sort of owned the screen real estate. And it's a very subtle indication of how that patient's doing. And mostly it agrees with the doctor. And so it builds their confidence that the system actually works. And then occasionally it disagrees, and it's creating just that little bit of friction. In addition, it allows a mid-level that is disagreeing with a clinician to say, instead of, I think you're wrong, why do you think the survival curve is in disagreement with what you want to do? So it gives them a way of challenging without making it from their personal expertise. All right, I'm going to switch gears and talk a little bit about some work on professional informatics. So I'm guessing you guys know about quantified self, things like Fitbits that collect data and give people information to reflect and make lifestyle changes. We have been doing this, but really thinking about professionals. So looking in spaces where there's a detailed literature on best practices, where things are increasingly becoming instrumented, and where people don't regularly receive rich feedback that help them improve their performance. And we've been working on some smart classrooms where we're trying to record what is happening. So what is the teacher's action? What is the student's reaction? And how do we capture that and feed that back in a way that teachers find valuable? We're looking at two different contexts: high school science classes. In the high schools, we're only using audio for a bunch of privacy reasons. And so we're focused on an effective discussion and awareness of like how much time is the teacher talking, how much time is the student talking. In the college space, we're looking at STEM classes. We're only using video, and we're focused on immediacy, which is sort of a set of nonverbal behaviors instructors use to show students that they're cared about. And those co-vary with student engagement, which co-varies with doing well in class. So for the high school teachers, they're seeing visualizations like this for a discussion, and they're really looking for sort of like, I'm trying to get students to give explanations with evidence. I'm trying to like drive an increase in that behavior, getting students to be a little more metacognitive. And what we're doing is giving them transcripts of the discussion sort of coded so they can find these moments where they got this explanation plus evidence, and then look backwards and say, what did I do to get a student to produce that result? And the teachers were super interested in this. They would look, recognize their own behavior, say, oh, I can't believe I did that. Next time I really want to do this. So they could see it, notice an opportunity for improvement, and set a goal for the next class. With the college instructors, we were really showing them where they're giving their time and attention, and the teaching is much worse in college. So it was like, oh, 40% of your time you're looking at your laptop, and 40% of the time you look at the board behind you, and you're really only giving 20% of your attention to students. And we got a very different reaction. So we're sort of practicing some different visualizations, but we got a very different reaction from the college professors, which is they would blame the room. They would say the students here aren't very good. Or they would say, I don't really believe immediacy matters, which is very different than the high school teachers. And we were wondering, like, why are we getting a different reaction to the same technology? And it's made us think there's actually a difference, and maybe characterizing college instructors as amateurs and high school teachers as professionals is a better lens for thinking about this. So college instructors, we know, think of themselves as domain experts, but not necessarily as teaching experts. That's very different for the high school teachers who have had a year of professional training on how to teach and do 100 hours a year of professional development working on their teaching techniques. And we began to really think there's a difference between something that is core to your sense of self in a professional role versus a responsibility that you have. So college professors have a responsibility to teach, but don't view that teaching as core, where the high school teachers definitely were viewing teaching as core. All right, I'm going to make a sort of another conceptual move and talk about some work we've done in robot re-embodiment. And this is sort of very different work, but we're trying to explore when is it appropriate for robots to do very non-human things. So in human-robot interaction, often human-to-human interaction is put up as the gold standard that we're trying to achieve. But robots can do things people can't do, so should they? And there's some great service theory that shows people want a single point of interaction with a service. So if you buy a phone from someone, I buy a phone from Steve, and then my phone breaks, I really want to take it back to Steve and say, Steve, fix my phone. But there's an expertise problem because the expertise of selling a phone versus repairing a phone are two different things. And so services generally have people dealing with a whole bunch of different agents based on the expertise of the different agents. But do robots actually present an opportunity to sort of more singularize this, where you actually do have a single point of contact? And in current robot behavior, there's this sort of one-for-one model where sort of one robot has one social presence, or what we refer to as an all-for-one. So this is things like Amazon's Echo or Google Home, where kind of it doesn't matter which one you use, you're always sort of talking to the same entity, but there's sort of an entity in a cloud and you're just using the device to get to it. But there's this possibility for these other robot behaviors, which is re-embodiment, this idea of a robot social presence jumping from body to body, or co-embodiment, the idea of many different social presences simultaneously being embodied in a single robot. And so we've done some work with speed dating using user enactments. And speed dating is a process where we give participants a sip of many possible futures to get them to critically reflect on the future they want. And we tried this at the Department of Motor Vehicles. So we simulated that space, had people come in, you check in with a robot, and then you go to the first station and it's going to take your photo for your driver's license. And so that social presence of the first robot you checked in with jumps into the next robot. It remembers who you are, why you're there, greets you by name. But this one has a camera, so it can take on that activity. Then it jumps into the next robot where you go for your eye exam, so you're sort of moving. And participants really liked the idea of being followed through a servicescape and supported on sort of completing their task across all of the touch points. But when we tried this exact same thing in a health context, we had them come in and they check in and they would go and get an MRI. People had a very negative reaction, and they said a really interesting thing, which was, I don't think a robot that checks me in would be smart enough to take an MRI. And so they're making a human judgment on social status and expertise, and using that to sort of say there's a barrier between these two roles, and when you violate that, it makes me uncomfortable, even though robots wouldn't have any trouble overcoming this expertise problem. So this became very important to us. We started to explore this with storyboards, looking at several contexts. So here's an example of a storyboard we used in a test. So it's Thanksgiving, so it's a holiday weekend. Jerry's flying home. He hands his ticket to the boarding agent. The boarding agent checks him in, and then the boarding agent sort of re-embodies and becomes the co-pilot. And so Jerry's sitting on the plane. He hears Bob's voice over the intercom, reintroducing himself as the co-pilot for the flight. So we're trying to just test this idea with people. We looked at 4 different contexts. So we looked at a hotel where we had a maintenance worker that also did room service. We had a maintenance worker that also became a concierge. We looked at the airline, so boarding and just also being your in-flight entertainment, or boarding and co-pilot. Personal care, so getting a haircut and also getting a massage, or getting a haircut and getting physical therapy. And then finally a dentist, where a robot checks you in for parking, but also does reception, or a robot checks you in for parking and also takes the role of a nurse. And we got a really interesting set of reactions in these histograms. The indication, like when they're stronger on the left, that means people are more accepting versus less accepting. And for the concierge or room service, people were pretty accepting of that. Oddly, the pilot was not nearly as negative as we expected. But the haircut and physical therapy was highly negative. And the nurse was highly negative. So we're definitely seeing some boundary conditions on where can robots sort of encode a number of expertise, and what are the boundaries that they shouldn't cross. So I just want to step back and think from a higher level about professional AI interaction and what we've learned. And come back to the idea that the selection of an objective function of, like, what is the inference you're going to make, and what are you weighting in terms of that inference. If you're making something to support an actual professional, you don't want to automate something that is core to their identity for the work that they're doing. So in exactly the same way parents didn't want us to automate parenting, professionals don't want you to automate the core decisions that they make that are connected to their identity and performance of that role. You can offer very non-human insights and perspectives on the decision. So if you can chew through a non-human quantity of information and offer it, not making the decision, but in support of the decision. So like, we can look at a survival curve based on an analysis of 1 million patients, but we're not telling you whether to have the surgery or not, just offering this different piece of information that informs the surgery. That was very much appreciated. You can definitely automate the mundane, you can reduce stress, and you can free attention as long as that attention is back towards the professional sort of doing the work that's core and is focused on the long-term goals. And for these core activities, you can give rich feedback on their performance. And professionals, even without structure, can take that feedback, can make sense of it, and can do goal setting in terms of their own self-improvement. But when you're looking at a responsibility that's not core, you really need to offer feedback that has a lot of scaffolding on how to optimize. So when it's the professional, let them choose how to optimize. But when it's really just that responsibility, they want a lot of scaffolding. Just tell me what to do, don't tell me about it. And very much they have an interest there is what is the least amount of effort I can put in for better results. In thinking about professional AI, so like when should we have a robot or some other system that's taking over a profession, but they're sort of doing it in a way of an AI versus a professional working with an AI. There's this issue of professionals are more than the skill and expertise and the intuition. Being a professional is a social performance, often in front of the customer. So whether you have a robot doing it or a human doing it, how are you working in support of the performance that is fulfilling to the human professional, but also fulfilling to their customer? And one example that I've run across here, there's some really good work in computer tutors where a computer tutor, like for something like algebra, is really good at recognizing at exactly what is the core concept a student doesn't understand, and they can feed them problems to get them to work on different aspects of that and can recognize when is the student just about to have sort of a conceptual leap and go from not understanding to understanding. But when the student makes that leap, the AI can't validate the student. They can't make them feel good about the fact that they've made a gain, but the human teacher can, and human teacher will get bored sort of drilling and killing on this small aspect. So you can think of this as an ecology where you're trying to bring the human instructor over at that moment the child's having a breakthrough. The instructor likes it because they're getting the credit for teaching. The student feels validated, and you have a very efficient model. So sort of, do you understand how these three roles are interacting in an ecology? When you start to think about replacing a professional with an AI, you want to think about what is the bounding action space that they're in and what is the identity that maps to it. So people were very uncomfortable with kind of AIs in the role of a professional that were doing more than what that professional is supposed to do. So that seemed like a pretty clear bounding, although I think that's still a fairly open research question that we want to keep probing. And there definitely seems to be some aspect of risk. So when the decision the professional was making became more high risk, that's when that bounding became much more clear for our participants. And then finally, this idea that customers are people that arrive with data. So whether I'm a patient, I'm arriving with data for the professional, or I'm somebody that bought a phone, whatever it is, there's data behind this. And when supporting a professional, we want to help them enact a more effortless performance of the expertise. So there is a value in getting in and processing the data and extracting out insights that professional can act on. But it should be done in such a way that the professional's attention isn't on the data, but now it's really more about being on the customer. And that the customer is not their data, they're this person in the transaction. So how do you free up that professional's attention to really validate and support what the customer needs in that action. Okay, I'm going to stop there. Thank you for your attention, and I'm very happy to take questions on what we're doing.
Okay, thank you very much, Professor, for the very interesting talk. We still don't have many questions. We have here one question already that I can ask you from Tiago Guerreiro. So related to the acceptance of roles, it seems people are more okay with roles that they already perceive as semi-automated. This is the case of pilots, where generally we accept that an automatic pilot is already doing a lot of work. This is transmitted in movies, books, etc. How fast are these perceptions changed? And what is the role of media and entertainment in that change? Can we and do we want to signal a more optimistic idea through these media?
So let me touch on that in a couple of different ways. So yeah, people's perceptions of what technology can and should do, those role boundaries do change. What we found, so when we were testing our scenarios, we had a version where the robot that checked you in was the co-pilot, but we had another version where the robot checked you in and it was bounded to that role, and then a different robot was the co-pilot. People liked that one more. So even though they're fine with automation, with that automation, they still wanted a definitional boundary. We did another one with co-embodiment where you were in a driverless car, it was driving you, and then your Echo dropped in to talk about the need to purchase new windshield wipers, and Echo was talking to you as the passenger, but also talking to the car, and people became very disturbed with that. It's like the car should be driving. It shouldn't be driving and doing other things, right? And it's this very human sense of a singular locus of attention, which is not at all how computation works. And that may change with time, but right now, as people are making this transition to intelligent things, they're bringing a very human sense for how that intelligence is working, even though we know these intelligence are in no way human. But we have to span that gap, and it's not clear, like, when should I be more transparent and make it very clear this is completely not human, and when is that helpful and when is that actually harmful to the transaction that's taking place? That is still a huge open question, but I do think media plays a role. I would say mostly media plays a role in creating unrealistic expectations and also reinforcing that machine intelligence is like a human intelligence. And that is a conflict we're constantly dealing with.
Okay, and related also to that question, how do you gain people's trust of AI technology? Or is people's mistrust of AI the limit to using this kind of technology?
So often, so we found in some other work we've done and other literature, trust is more complicated than trust. And there's some great work from Cliff Lampy that we've been building on where he's been looking at creepiness. And so he was finding like systems that take your data and let you know they're taking your data and very transparently feel creepy, right? It makes people feel bad and you don't want to use the service. But if that service, when it's revealing, it's collecting data from you, also delivers something you experience as valuable in the moment, that feeling of creepiness goes away. And so we did this also sort of in a space of trust when we can deliver something the customer experiences as valuable to them. Their sense of trust or distrust disappears. But when there is no value and they can tell this computation is taking place, that is where that distrust comes from. So instead of like thinking it's about transparency, actually we would say a much safer or more effective path would be to make sure you're delivering something that someone experiences as valuable.
Okay. Another question from Laura Ferreira. She said that you had very interesting examples today. So your examples made me reflect on how professionals make decisions and how their decisions mechanisms function. Interestingly, the most seasoned professionals skip a lot of decision steps and often are not aware they analyze the information they had at hand to make their decisions. Do you have any work on how AI can influence or not influence professional decisions?
So I would say, like, it's super challenging. There's some great work in nursing about nursing intuition, where nurses can recognize patients that are likely going to die in the next 24 hours. They're very sensitive to that, but they can't tell you why, right? I just can tell. And so when we think about we're bringing an AI in to support clinical decision-making, the AI is using what is in the medical record, but there is way more information that the human is using in terms of their judgment. And so I think we often mislead ourselves into thinking we have a clear record of all of the elements that make up the decision because I have this digital trace. But there's a lot more that's going on. So I think it's about finding the balance. How do I make something that's supporting a professional, but doesn't interfere with their intuition? So some work on detecting cancer from pathology. So pathologists see an image and they say if there's cancer there or not. The way they work is they kind of like you recognize your mom's face, like you recognize that's my mom, but you can't say why. They can see cancer, but they can't tell you why they see cancer. And when they gave them markup, so the AI indicated, these are all the reasons I think this may or may not be cancer, it undermines the professional's ability to sort of read it and make a choice, to make a judgment. And so they designed a transactional flow where you first show an unmarked up one, and then they make their judgment, and then you show the markup and they reflect on that. So really thinking about the sequencing. The other thing is, can you surface information? And so like with the teachers, they're very good at teaching, but it's hard for me to tell, like, am I giving equal attention to all of the students? Do I look at the students on the left more than the students on the right? In terms of like my own fairness and accountability, do I call on more male students than female students, right? These are, we know these things from the literature happen, but they're very hard for someone to maintain an awareness of in the act of acting as a professional. So to me, the action space to a large degree is a rich feedback system to the professional on what they're doing, where they can make a judgment of how to make a change without losing that access to their intuition and their expertise. And this is, I think, highly under-investigated. Pretty much most of the systems we build are like, I'm just going to focus on the professional's decision and call that ground truth because that's sort of the easiest thing to do from the data. But that's not the most helpful thing for the situation.
Yeah. Okay, so we have a lot more questions. So from Jefferson Lima, which tips can you give to improve the way we access data, mainly when the customers have special conditions, like people with dementia, for instance?
So I'll push back like a more radical view here. We know when you receive personal service, like if someone cuts your hair, it can develop, you can develop a sense of loyalty to that service provider such that if you were to go to someone else, you actually feel like you're cheating. And that is a very different relational attachment than you have to like airlines, which have loyalty programs which really aren't loyalty at all. It's about reusing a service because of additional perks you get, which is nothing to do with human loyalty. And so they've sort of they're sort of focused on the wrong thing. When an algorithm does something amazing for you, you don't experience it as having made an effort for you in the same way like the person cutting your hair. You experience like their effort, and it changes your perception. So can we use the utility value of digital personalization, but can we deliver it to a professional so they can personalize their service to the customer, where you're getting all of the power of the digital plus all of the power of the human simultaneously together? And how do you do that in a way that is about improving the quality of the professional's work, but also improving the satisfactory experience of the customer? We want to sort of maximize both sides of that. And this is where I really think we're often not trying to replace a professional, but we're trying to make them a super professional, but super in a way that that customer experience is also. And it's not just about speed, but it's about the quality of the insight they can bring to the decision that professionals supporting that customer through.
Okay, thank you. Another question from Tiago Guerreiro. There is a trend to explainable AI to respond to the increasing role of AI in critical systems. Do you think unremarkable AI is an alternative that is likely to minimize the need for explainability and that it can be incremental?
So I think explainable AI, we haven't seen it work. And it's supposed to increase trust. But like I said, trust is a little more complicated. If something is telling you something that's wrong and then explains it, are you less annoyed, or are you still annoyed that it's wrong? And I think it's dependent on sort of where is its input and how is it having a negative impact on you. If we had spam filters that explained why they were marking things up as spam, that would really be awesome for the people sending spam messages to circumnavigate the systems. And I think people want an explanation when something breaks, when it doesn't work the way you want. But the explanation is only valuable when it helps you adapt your behavior to improve the quality that you're getting from the AI. So I think it's not like explanations are good or bad, but how it's situated. Does it allow a user to adapt their behavior and improve the performance towards the user's goal? Then that's an awesome explanation. When it's not doing that, just telling me like, yeah, we kind of suck at this, that's like, yeah, that's not helpful.
Yeah. Okay, another question from Sarah Eloy. In the case of the clock for kids, it's not clear how it enables kids to make decisions. By presenting them 3 scenarios, you are imposing them a behavior and therefore removing their possibility to decide. Can you please elaborate on this?
Yes.
Also, yes, okay. Yeah.
I covered that at a super fast, but I can give a little more background. When you have a child that is under 4 years old, they have no sense of duration. So if you've ever heard like a little kid tell you about like their trip to the zoo, it is just a string of experiences that make no sense. There's no narrative structure. But that is their experience of the world. So what happens with them is they will wake up, go to their parents' room, because they're now like able to get out of a crib. I can go there. And sometimes they wake their parents up and their parents are delighted to see them. And sometimes they wake their parents up and their parents are super pissed off and tell them to go back to bed. And from the child's point of view, their parents are wildly inconsistent. And so we were trying to deal with the child has no idea, is this a good time for me to get out of bed or not? And so the idea of the clock, just having these 3 states, is really as a guide, because they have this inability to assess how much time has passed. And so that's the cognitive user that we're dealing with. And that was really the driver of those 3 states.
Okay. Sarah has another question. So what are your thoughts about technology removing people the possibility to decide, as well as removing the belief that people have that they can decide at all?
So this is kind of very core to our work when we're making systems for professionals. And I think it's very much like that thing that matters to the professional. That's where you don't want to make that decision for them. That is what they do. That is their skill. But how can you give them new insight that is helping them improve that decision making and to experience greater value for the decisions that they are making, and to sort of have that stronger connection, social connection with the customer that they are supporting. That's where we see as a super rich space for AI, but that's not a lot of decision making. A lot of decision making people do is super mundane. And so that's the safe space to really think about automating the things that don't matter. I don't know if you guys have used like Smart Compose, where you're typing a sentence and you're halfway through and it offers you, because it's sort of like almost everybody else that's written a sentence like this has ended it like this. That's super reductive, but mostly we're not writing, every sentence isn't particularly important. It's kind of pro forma. And so, yeah, if you're helping me speed up the mundane, repetitive parts of my life, awesome, because it's freeing up my attention to really work on the things that matter, where I need my creativity, and I'm not just sort of doing the routine. So I think we can find that balance and automate a lot of stuff away to free up people's attention to do that connection with other people. I think that's what we should do.
Okay, so we still have 8 more questions and our time is almost up, but I think I will ask you 2 or 3 more questions. So from José Dias, I see from your keynote that AI should aid the professional more than to replace him or her. But don't you think that some professions are going soon to be fully replaced by AI? For example, in the legal arena or in the manufacturing or agricultural sectors, among others?
Yeah, and that's why we're looking kind of at the robots that are full replacements. And I think you kind of want to make a bold choice. I either want to fully replace you, and maybe it's like a lower level status system that could help you. You know, it's like an AI lawyer that helps somebody who has a textbook problem versus a person that needs a lawyer for a super delicate specific situation. So I do actually think we want to do some replacement for, again, the most mundane routine things where the patterns are very textbook, but where you need that human creativity. AI does not work well where there aren't a lot of cases to guide it, right? Deep learning works when I have hundreds of thousands of training examples. It does not work well. I have like 5. This is not going to offer me much for that. And that's where we need. So to me, like understanding how we define that boundary line is still very hard.
Yeah. So I will ask you 2 more questions and then I will pass the floor to João Guerreiro to close. So from Agnes, how would you convince a regular person that AI for medical imaging is way better than a radiologist?
I wouldn't yet. I think when we can show an order of magnitude better performance. So I don't know if you've seen the guy in Switzerland who does drones, and he has drones do things like catch a ball, balance a pole, throw a pole, and another one catches it. Like, these drones can put themselves into space in a way a human pilot couldn't. There's absolutely no way. And so I think it's like, when are we so much beyond human capability that it would be dumb not to have a machine do it? And I think when we're just going up to, well, it's about as good as a person, we're nowhere near where we need to be to do that replacement.
Yeah. Yes. So the last question, I'm sorry for the remaining questions, but our time is up. So from Claudia Silva, I'm from IST. Thank you for this talk. I was wondering if Dr. Zimmerman could talk a bit about AI and ethics. Some AI scholars have made the point that the AI is not ready yet or not developed enough to make certain decisions. What does he think about it? Has he seen it in his own research? Any interesting case to share on this note?
So I'm doing some new work in that area. We are looking at, so I think the ethical questions have a lot to do with training data. They have a lot to do with bias and tuning, but they also have to do with where decisions are more social. So things like a smart compose, like it's less of an issue there than when I'm like deciding if you should have a surgery or not, or I'm deciding who should get a loan. And so I think it's like, what are the consequences of the choice? But we don't have good mechanisms for bringing those considerations in. Oftentimes, I think a better solution is to go back to the objective function. So they're using these AIs in law. Judges will use them in sentencing guidelines where it's estimating the likelihood this person will commit a crime in the future. So that's a choice to make that the objective function. You could also say, my objective function is to rate whether this is fair. This sentence would be fair in comparison to everyone else that's been sentenced for the same crime. And I think often there's not a lot of searching done or ideation around what is the insight we can produce from the data that's supporting that human decision maker. And it often gets very reductive, and that's where you're getting these ethical conflicts.
Okay. Thank you very much. So I will now give the floor to Professor João Guerreiro for the closing remarks. Thank you.
Thank you very much, João. First of all, I would like to thank John Zimmerman for this excellent talk. This is a very interesting and timely topic, and your work and the number and quality of questions are a great example of that. So thank you. I would also like to thank all attendees for their participation and also the questions they performed. We could see that they were engaged in this talk and in this topic. And to remind everyone that this is the first of a series of 3 talks on user experience design, and that will have 2 more exceptional researchers talking about their work. And that we expect to have everyone here again. And I think that's it for today. We're already past the time. So thank you very much. And again, thank you, John, for this excellent talk.
Thank you.
Thank you.